So we have a couple of assumptions to use KNN algorithm. Okay, first is feature homogeneity. Okay, so this we have learned in linear regression as well. Okay, homogeneity of the data means all the data that you are trying to measure distance from, so that should be similar type of information. One can't be height, one can't be weight. Okay, so you can't measure the distance that way. So homogeneity should be there. Okay, similar data, you can calculate the distances only between similar data. That is one. Second thing is, because this is the assumption, so that means the features on different scales will lead to incorrect distance calculations. Hence it is essential to standardize and normalize the data. Okay, that is one first assumption. Second assumption is you have to choose relevant distance metric. Okay, either Euclidean or Manhattan or Minkowski, whichever it is, you have to choose it accordingly. If you don't choose it, then what will happen, the accuracy will take a hit. Okay, so for example, Euclidean distance is for continuous features. If you use something else in place of that, you will get the inaccurate measurements. So that is inaccurate distance calculations. Next is locality of the data. That means data points that you are trying to measure should be in the same dimensions, same feature space. Okay, so one that is what, again coming back to that height and weight example, one feature cannot have height and weight values. Okay, so locality should be there, otherwise calculations, they will be incorrect. Okay, and high noise would be there. Next assumption is there is sufficient training data. In order for you to get KNN to be used, you can't have just 10 rows of data and then use KNN. It simply doesn't work that way. You need sufficient data to cover the feature space. Okay, so that is the thing is KNN performs better on large data sets. Insufficient data will not give you the correct decision boundary. So that is another assumption. And independent of instances, this is same as what linear regression is. Correlation between two features should not exist, so features should be independent. Okay, so that is another assumption. And balanced data, this is very important. So if you get like what we saw, if you get 25% of one class, 75% of another class, then distance metrics calculated will be highly imbalanced and they'll be biased. Okay, so that's why you have to have balanced data. To get balanced data, you have to do oversampling or choose the class weights. So that's why you have to change the class weights metrics to distance instead. Okay, again is curse of dimensionality. So curse of dimensionality is nothing but if you have too many features in your data set, okay, then that will lead to poor performance of the model. And this curse of dimensionality also holds true for linear regression and logistic regression. You can't use logistic regression on at least not specific solvers. Okay, except for liblinear, you can't use other solvers for high number of features. Okay, so that is curse of dimensionality. So somehow we have to compress all those features into 2 to 3 features. Okay, that is what we call it as PCA. Okay, PCA technique is used there. Okay, these are assumptions. And advantages is it's very simple, as you saw, very simple calculations, and it's versatile. That means it can be applied for both classification and regression as well as multi-class classification problems. And apart from the above ones, there are not many assumptions to go with it. Okay, adaptability, it can be adapted to any new data. Feature interactions, basically it will capture the interactions between features because you're using distance metric. Feature interactions are calculated using distances. Okay, now what are the disadvantages? Disadvantages is computational complexity. As you saw, if let's just say your training data had 10,000 examples and you have to do the prediction on million let's just say 1 lakh records, then what will happen is each one of those row of 1 lakh records has to be calculated, distance has to be calculated against those 10,000 records. So computational complexity is high here. So that's why if it is a large data set, you can't use KNN. It becomes difficult. Okay. Again, we'll talk about how to mitigate that, but just remember that for now. And memory intensive. Okay. Um, Memory intensive is, it takes a lot of memory to do this, hold these calculations. Okay, so space complexity is also there, computational complexity is also there. And if there are irrelevant features, redundant features that don't really affect the distance calculations, then you have to do the feature selection and L1 regularization. Okay, but as you saw above, if you just paid attention, you have p value here. um, okay, p value is not regularization. As you saw, regularization is not inherent parameter here, although you have star here. Okay, which means you can bring your own functions, custom functions as parameters, but you don't really have the regularization option. Okay, so so in that case what happens is you have to do the proper feature engineering, feature selection, and um, normalization that become necessary in order to mitigate the redundant features. Next is curse of dimensionality is another problem, as we already discussed. Too many features will increase the complexity as well as poor performance, where you will see class imbalance is another problem. And the choice of k itself, you have to find out the k first to be able to use this algorithm. That is another disadvantage. So these are all interview questions, so you just have to know. Okay, next we will move on. Okay, of all these things that you learned today, you must have paid attention that the only challenge in getting these is when you bring a new data point, you have to calculate the distance between. Just give me one quick minute, please. Doctor is calling. Just give me one second. Yeah, hello, doc. Yeah, hi, doctor. So would you be available at around 12 p.m.? Um, 11:30, is it? Okay. No, because I actually conduct classes on weekends. I'm in middle of class actually. Um, I can, or can we do it tomorrow? Or Monday? Mm-hmm. Actually, doctor, I'm so sorry. So I forgot to mention yesterday. We're going out of station. My sister has given birth to a baby, so we'll be going out of station. Um, yeah, Monday. Yeah, yeah, please. Yeah. Thank you very much. Yeah, yeah, Monday morning. Yeah, thank you. Thank you. I'm so sorry about that. So that was little important for me. Okay. So eh, I was saying the only challenging complexity you must have seen is when you want to do the prediction part. Okay, you have to measure this, bring this new point and measure it against 10,000 rows of data. Okay, that is a challenge here, computational challenge. Now, how do we mitigate that? Is there are three different options. What we saw here in this example is something called as brute force. Okay, so there are three options. One is KD tree, another one is ball tree, another one is brute force. Brute force means you compare it with against everything. Okay, so that is what we did here. That is apparently is not a good option. Instead we have KD tree and ball tree as the two different types of calculation uh, metrics. Okay, and not metrics exactly, the different types of calculations. Okay, so in brute force, basically you, here the distance of the data point, you calculate it against all other data points. So this is the difference. Okay, so just like what we did, hence your complexity of the algorithm is, if you have d dimensions and n number of features, then it's very high, d squared complexity, it's a squared complexity. Okay, hence it is a approach. While choosing the algorithm, you should always specify either KD tree or ball tree. You should ensure that. Let's quickly look at confirm what is the default option in the algorithm. One second. I remember seeing it as auto, which means it will automatically choose. But let's just still have a look. Yeah, so algorithm was auto, which means it will choose automatically between one of these three. Okay, ball tree will use, yeah, okay, will decide most appropriate algorithm based on values passed. Okay, so in that case you don't have to worry much about the algorithm, but in case you want to experiment which will give you the best result, okay, you can use these as hyperparameters and choose which algorithm will give you the better results and use it. So essentially what I'm trying to say is, if you have too many number of rows of data, don't use auto, don't use brute. Okay, that is what I'm saying. Instead try using KD tree and ball tree. KD means k dimensional tree. Okay, use this k dimensional tree, look at its complexity. It's a log complexity. Log complexity is much simpler than squared complexity. Okay, so what you can do is, you can either choose KD tree or ball tree. Ball tree has much simpler complexity. So basically KD tree also becomes inefficient if you have too many columns in the data set. Okay, in that case you can use ball tree, or by default you can go for ball tree. Okay, so what this will do is, this will determine which are the closest rows that are to the predicted one. Okay, beforehand, before you bring the data point, just by looking at the x and y values. Once it determines, now instead of 10,000 rows, it will only try to calculate the nearest neighbors with, let's just say, 1,000 rows. So 10 times improvement there. So let's look at very quickly on a shallow level. Let's understand what KD tree does. What KD tree does is, basically in the all your training examples, it will look at all your x values, 1 2 4 3 5 6 7, as you could see, 8 7 9. It will choose those values, it will sort those values, it will find the middle value of those points. Okay, it will find the median. Either it will choose x values or it will choose y values. It will do it randomly. Random dimension is picked and the values are sorted, and median is obtained. Once it obtains the median, it starts splitting those x-axis values. Okay, and in the next iteration it repeats the same thing for y dimension, and y dimension also median is found, again the data split is done. Okay, and this step is repeated multiple times. Okay, multiple parts are obtained. Finally what you would have is, so once you get the median, okay, once here x is 6. Okay, 6 is the middlemost value here 6 is the middlemost value. So basis on that 6, x is taken as 6. Okay, for if x is 6, what would be the y value? So it is separating out the data points. Okay, some sort of you can understand it as some sort of clustering, but based on the median value. So this way it will draw the decision boundary. Now if your new point that you bring falls here, it will compare only with these points, the points which fall between 6 to 10 on x-axis and 0 to 8 on y-axis, only these points. So basically it's separating out. Instead of comparing with all these data points, you will be comparing only with these three, and basis on the k value you will choose the regression value or the classification value based on the majority voting. Okay, this way KD tree simplifies just by choosing the dimensions, by calculating the median value on the dimensions. Okay, this is KD tree. I'll give you the link to this, you can go through. Okay, next is ball tree. Now ball tree, what it does is, okay, consider this data. So basically it will start looking at the data points. So it will select a random point, let's just say 5.6, 5,6. Okay, for 5,6, the point that you brought, okay, so basically it will measure the farthest point, which is the far away point from the random point that it has chosen. And once it chooses, okay, again it will, from there on it will find the random point, that is the farthest point. Here 7 and 8 is the farthest point. So that means from 1 to 2 to 7 to 8, it has calculated that they are the farthest two points in all the data, and now it projects all the point on that line, nothing but your best fit line. It's somehow trying to come up with the best fit line. Okay, and it starts projecting the points onto that best fit line, and now it determines the median of those best farthest point. So basis on this it determines the median, and once it determines the median, around that median it starts forming a cluster. Okay, a centroid, it will find the centroid, means a cluster. Okay, a circle kind of thing. Okay, here one circle will be formed. Yes, did anyone have question? Hmm. Mm-hmm. 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 Yeah. Mm-hmm. Yes. Yes. Correct. Correct. Yes. Yes, these points can be non-collinear also, if that is the question. Mm-hmm. Right. Right. Yes. Mm-hmm. Yes. Yes. Absolutely. Absolutely. You are. Mm-hmm. Correct. 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 So first randomly selected chosen point 5,6 is only to start measuring the furthest point. It is not there. Uh, yeah. Yeah. Yeah, first furthest point. It is used only to calculate the first furthest point. So for example, let's just say in this example, instead of 5,6, 3,5 is chosen randomly. Then the furthest point would become 8,3. Okay, 8, as you can see, 8,3, right? So now the calculation change. Yeah. So they could be collinear or non-collinear. Here in this example, it seems to be collinear, but it could be non-collinear also. Okay, so anyway, so final furthest line would be a straight line, and you start projecting all those lines onto the, basically you start calculating the distance between those points and the line, just like what you do in linear regression, and you determine the median of that line, and around that median you form a centroid, a circle, and this will become one cluster, this will become another cluster. Once you have two clusters, okay, basically the now your new point, if your new point comes, let's just say some point here, okay, So this process is repeated. I mean, first, even before you bring a new point, this process is repeated, so that you get the multiple circles. So that way you have multiple centroids. Now you bring any new point into this one of these circles, you immediately know which cluster it belongs to. That way you will be comparing the calculating the k value only with those, and basis on that you will be determining what would be its floating value or what class would it belong to. Okay, so this way this step is recursive. Okay, so what you did in determining these circles would be repeated again. Okay, um, so recursively you will generate the circles. So this is how ball tree will come. Ball tree will function. So as you can see here, if you bring a 8.5 here, now the distance is calculated only between the closest circles. Rather than 10,000 points, you would barely have, I believe, let's just say 100 points, okay, against which you will calculate. So there is a attached video also explanation. Yeah. Yeah, so I will. Mhm. Go ahead, please. They are not essentially circles. Circles are only indicated to for our better understanding. Okay, but they are just the centroids, as in some sort of clusters are formed, basis on which it will calculate. Yeah. Mm-hmm. Oh, okay, okay, okay. Up until this point, did you understand? Okay, okay. Here, till here. No, no, no. Okay, I will start from here. Okay, once you calculate the median, you will start projecting the points. Okay, simultaneously, you will calculate the centermost. You will take this median as the kind of a point, boundary point. Okay, and to this start first point. Now you will start drawing the circle. So you will use this 2.25 comma 4.25 as the center of that circle. So basically you have to come up with a circle such that it captures all the data points around that median, within that median limit. Mhm. 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 5 comma 4, this point. Black line. Oh, black line is very easy. Okay, black line is very easy. I'll explain. See, what did you do? You determine the furthest two points, right? For after you determine the furthest points, you calculated its length. Here in this case, 8.49 is the length of this line. Now you will divide that 8.49 by 2, half. Okay, you are dividing that line median into two halves. So this is the center of the complete line. Okay, correct. So you correct. Yeah. So this way you are drawing the circles. Once you draw the circles, again you are doing the same process. You are measuring the distance. Here 2.57 is the radius, here 7 is the radius. Okay, and if you bring a new data point, I mean this process is repeated multiple times, it looks something like this. But if you bring a new data point somewhere here, it will start measuring the distance between from the center of that centroid to the data point. Thereby it will classify whether this point belongs to this circle or this point belongs to this circle. Whichever is closer, this point will belong to this circle. So here 8, 5 will belong to circle number 6, centroid number 6. Okay, so that way classification is done. Or regression value is, it will take the average of it. 8 plus 6.5, 6.5 is already the average of all these data points. To that it will add, divided by 2, you will get the value. So prediction value basically. So you will get some regression value. So this way KD tree works. I will still attach this link. You can go through for solver's point. I will attach it at the bottom. Okay, so you can go through. It's a simple explanation, but once you understand, it's very easy. So this way KNN uses 3 different techniques to arrive at the measuring the K, doing the calculation with K values. Okay, so first we will do this classification part. Very easy, very simple. It won't take much time as well. Okay, so what we are doing is, we are just taking the cancer data. In the, here you have the sizes of the lumps that have formed, radius of the texture, okay, perimeter you have, area you have, smoothness, compactness. So a lot of features are there. These features belong to the lump sizes. And finally we have to classify whether the person has cancer or not cancer. We have to diagnose. Okay, so basis on these, so we have totally 569 rows and 33 columns. 33 columns is a big number, so we have to reduce that number, reduce that 33 number, and we will see what how we proceed. Okay, so in the data pre-processing, these are all just the common methods. You are doing handling the missing values. Basis on the missing values, you are going to determine which has the highest number of values, whether you will, and for these whether you will choose whether to keep it or not keep it, or whether to impute it with the mean values. So basis on that you can take the call, whatever the, okay, let me turn on. So basis on that you can actually decide whether you want to keep the values or drop it. So because we have only 569 rows, I will keep those. I would just impute those with mean. Okay, and for categorical values also you have to handle. So basically first you have to find out which are all the categorical features and numerical features. Basis on that you can choose the techniques that you want to follow. So in EDA we are just doing the understanding the distribution of the plot, because we have already told we want to find out if the data is skewed, whether any transformation has to be done. Okay, so we have seen that most of them are already decent enough to be used. Okay, so we are doing a pair plot also to understand the type of relationship we have in the data. Okay, this will take a time to generate the plot, but anyway, but again, see, one is distribution, you will see. So as you can see, diagnosis, density. So this is exhibiting some sort of how do I put it, uniform distribution, we call it, right? Actually, if you repeat Bernoulli experiments, trial and error method multiple times, it becomes uniform. But in this case, because we have only 2 values, I would say Bernoulli. But because you have multiple rows, see, if it was 1 row, it would have been Bernoulli. Okay, because you are repeating those Bernoulli multiple times, it becomes uniform distribution. Here little bit skewed, little bit onto the left only. Okay, so this way you have lot of rows What happened? The call got stopped. One second.